Okay, gentlemen, we have done the last couple of sections. We've been doing two things. The first, we started with translating a verbal model into an expression. Okay, just 4x plus 7 or something like that. Then what we did was we took a sentence and translated it into an equation. So we had an expression equaling an expression. Okay. Now today we need to take those skills and we actually need to go further, translating an entire problem into maybe even a couple of equations so that we can plug one into the other and solve it. We did a bit of that last year. Now, this doesn't really intend for us to know that yet, this information, but we're going to use that and we're going to talk about that information today. Okay? Now, there aren't really any terms that we need to discuss that we're going to be using. I mean, we're continuing with the same stuff that we've been doing. But now, we're not translating sentences, we're translating problems into equations. And these things can take some time. We may actually have some time at the end of the day today to go ahead and start working on these problems, and then I'll walk around and assist with some of your homework today, if we have some time, and I think we will. All right, so let's look at this first part. It says translate the problem into an equation. All right, first it says Martha has twice as much money as Heidi. Okay, Martha has twice as much money as Heidi. How can I write that as an equation, Jordan? So M equals 2 times Heidi, right? Martha equals 2 times Heidi. M equals 2H. Good. Now we've got number 2 here. It says together they have $36. Who can translate that into an equation for me? Joseph.
M plus H equals 36.
Okay. Now, you know what? I'm hoping it will let me. Yeah, it will. All right. So now I've got these two separate equations here, right? But you guys know this, and we talked about it last year. Whenever I have an equation that has two variables, there are an infinite number of solutions for these things. Let's just think about Martha, and I mean this first equation over here. This one. Will it let me? This one. Okay? I could say that Heidi has 4, so Martha has 8. I could say that Heidi has 12, so Martha has 24. There's no end to the numbers that I can plug in and find out. There's an infinite number of pairs that solve this. Okay? The same thing's true over here. I could make this 30, and I can make Martha 30 and Heidi 6. I could make Martha 15 and Heidi, what is that, 21. Okay? There are an infinite number of ways that I can break this thing down. Except with money, I guess there's not, because we can only go to 2 places behind the decimal. But you get the idea. Okay? The thing is, we need to be able to use both of these equations, that one and that one, to find out how much each one of them have. They've put a couple of restrictions on them, so we can do that. So who can tell me, what would I do? How can I change this so that I only have one variable in an equation? Edward. Okay, Edward says right here in this equation, instead of writing M, I can put 2H because that's what M equals. So I'm going to rewrite this second equation in green, but I'm going to rewrite it with 2H there instead of M. So I'm going to have 2H plus H equals 36. Okay? Now what do, Ben?
You can add the 2 variables.
And I get 3H equals 36. Good. Where do I go from there, CC? Divide both sides by 3. Beautiful. And now I know that Heidi has how much money, Eric?
She has 12.
She has 12. Good. Now I know that Heidi has 12. How do I know what Martha has, Tara?
You just multiply by 2.
I multiply it by 2 because we'll go back to that first equation, and it said Martha equals 2 times Heidi. So M equals 2 times 12. And what does Martha get, Alfredo?
24.
Martha has $24. Okay, let's see if that, I mean, we know it does, but let's just make sure that it satisfies our restrictions. Marta has twice as much as Heidi. That's true. 24 is twice as much as 12. And together they have $36. 24 and 12 does equal 36. So I was saying Martha the whole time. It's Marta. But it satisfies both restrictions. All right, guys, good job. Let's look at number 2.